This lesson is about the third law of indices. The third law says that any number raised to the power 0 equals 1, providing the number is not equal to 0, because 0 to the power 0 would be undefined. That means 1 to the power 0 is 1, 10 to the power 0 is 1, 56 to the power 0 is 1, 144,264,000 to the power 0 is 1. Why is this true? Well, let's have a look at an example. Below I've written b cubed over b cubed. Now we know that if you have the same number over the same number, you get 1. For example, 2 over 2 equals 1. 140 over 140 equals 1. Z over Z equals 1. So b cubed over b cubed also equals 1. Now if we go back to the second law of indices, we'll recall that when you divide two indexed variables, you get an answer by subtracting the powers. So let's have a look at this one here. Let's subtract the powers using the second law of indices. So b cubed divided by b cubed is the same as b to the 3 minus 3, subtracting the powers when you divide the numbers. 3 minus 3 is 0, so b to the power 0 is equal to b cubed over b cubed, which is also equal to 1. So this shows that b to the power 0, which is equal to b to the power of 3 minus 3, which is equal to the b to the power 3 divided by b to the power 3 equals 1. So any letter to the power 0 equals 1. Where it falls down is when the letter is 0. And if you're interested in that, you can ask your teacher to explain why it falls down in this proof that we've just shown you. So let's now use the third index law on some examples. Just keep in mind that I'm assuming that none of these letters that are bases are equal to 0. So let's look at the first one. The first one is t to the power 0. By definition, using the third index law, that answer is 1. The next one here, xy to the power 0, is interesting. The brackets mean that everything that's inside the bracket is the base. So the x and the y and all the brackets are really the base. So that whole base to the power 0, again, equals 1. In the next example, 17 to the power 0, again, 17, or anything to the power 0, providing it's not equal to 0 itself, which 17 obviously isn't 0, is equal to 1. The next one's a bit tricky. There are no brackets around anything, so really it means 5 times x to the power 0. By separating it out like this, you can see that the 5 is not to the power 0, only the x is. So only the x is to the power 0. That means that when I do the next step, I will get 5 by 1, because x to the power 0 is 1, and the answer is then just 5. So there's a trap for beginners. There's a big difference between these two questions here. In the first question up here, the bracket means everything inside it is to the power 0. In this question, the second one with 5x to the power 0, only the x is to the power 0. Just watch out for that. In the next question, we've got a similar thing. 5x is inside the bracket, so all of that base is to the power 0, so it's equal to 1. The 2 doesn't have any powers, so it stays 2. And because we use BOD maths, we're doing the bracket, the powers and the multiplying part before the adding. So I'll do the addition now. That's the last thing I'll do. And the answer will be 1 plus 2 equals 3. In the next question, the last one, again, there's a plus in the question. That plus has to be done last. So you do the powers before you do the plus. 5 to the power 0 is 1. 3 to the power 0 is 1. Now I can add the two answers together and I get 2. So some things to watch out for when using power 0. First of all, watch out for where the brackets are and watch out for where the pluses are. Both of those things affect the answers. Here is another example using the third index law, but also the first and the second index laws. So in this, I'm going to do the same as we have before, which is gather all the normal numbers on the left-hand side. So if I look at that, I've got 9g to the power 7 times 4g to the power 4 divided by 6g to the power 3 multiplied by 2g to the power 8. So for all of those numbers that are there, I've got 9 times 4 divided by 6 times 2. I look at the g's that are left. We've got g to the power 7 times g to the power 4 times g to the power 3 times g to the power 8. Now let's have a look. 9 times 4 is 36. 6 times 2 is 12. If I divide those, I will get 3. Now let's look at the g's. On the g's, I've got on the top, I've got g to the power 7 and g to the power 4. And on the denominator, or the bottom, I've got g to the power 3 and g to the power 8. That means the first law says I must add the powers on the top line because those two terms are being multiplied. So it'll be 7 plus 4. The g to the power 3 is in the denominator, so it needs to be subtracted, its power, so the 3 needs to be subtracted. The g to the power 8 is also in the denominator, so its power needs to be subtracted. Now, if you look at all that, you only get 7 plus 4 is 11, take away 3, take away 8 is actually 0. So we end up with g to the power 0 over 1. Now, g to the power 0 is actually 1. So that ends up being 3 times 1 over 1. When you multiply or divide by 1, you end up with the same thing, so the answer is 3. It was certainly worth simplifying this huge thing up here because it simplified to just 3.